Dr. Saurav's classes, and today we are solving ISI M.Tech PCB 2025 solutions. So we are being given an array of integers. Your task is to do what? To determine the maximum possible sum. So here, for example, it's been given, then we have to maximum it's 6, that is attend for s equal to 3 and t equal to 6. So we have to write a function which computes maximum given an array as a pseudocode or in a programming language of your choice. So note that you will be awarded 6 marks for writing a correct code and 6 marks will be given based on the efficiency of code. So the problem summary is you are being given an array. So now you have to determine the maximum sum of a continuous subarray, for example being given like this. Okay. So here cadence algorithm, correct. Cadence algorithm. We are looking so efficient. So the code we have to write the function. So it will be like MATLAB function max subarray sum current global from to length a. Okay. So here maximum current okay, and beside I. Okay. So here if is greater than max global and max global is equal to max current, then finally what you will write? Return max global. This is a function which computes. Now in a programming language, here I have told you for MATLAB. Okay, the code. Okay, now if you ask me about the Python way, then how you will write? If I use Python, that way I told you, then it will look like so sum max current is equals to max global is equals to a. Okay, so for I in range max okay, so if max global, so max okay, so we'll return max. Okay, so here time and space complexity is what? Time will be and space will be only a few variables used. Okay, so here next is we used, argue why your code is correct. So we used to solve the maximum subarray sum problem. Correct? Now why it is correct? Because first, at each index I, the algorithm decides whether to extend the previous subarray. Okay? So maximum so here it is max current. Okay, plus a I. Okay, or we can start, or to start a new subarray from whichever is greater, it is chosen like this. Now why this works? Okay, so dynamic programming principle is applied here. Dynamic programming principle. Okay, so we remember the best solution ending at each index is what? This one. Okay, so we will track the global based so far. When? Obviously it is for global, so it will be like this. Correct. Now base case initialization, like max current is equals to max global. Okay, max global, that is max current is equals to max global is equals to a theta. What it ensures? It ensures algorithm works even if all numbers are negative. Okay, next inductive step, that is if max current is equals to max ai or max current plus ai, it computes the best sum ending at position 1. Okay, so because all sub array are considered like either by extending or restarting, the algorithm is guaranteed to find the maximum sum over all possible contiguous subarrays. So let n be the length of the array, then the algorithm will be let n be the length of the array. Okay, So the algorithms, it's iterates once through the array from index 1 to n minus 1. So does here does constant time operations like comparison, addition, maximum check at each index. So hence, as I told you, the time complexity is this, and the space complexity is this. Only two variables. So this is optimal. So this algorithm is correct. Why? Because it applies dynamic programming by maintaining a local and global maximum. So at each step, it decides whether to continue the previous subarray or start a new one to maximize them. So since it processes each element exactly once and uses constants, where the worst case time complexity is this one, and space complexity is this one, where n is my what? N is the length of the array.